Hey Year 12 and welcome to this next episode of Mathematical Mo Brain Movies. As you know, we're working through a short series on tips and tricks for trigonometry. I actually just did a little trick myself then, just did a little backflip, so I'm really sorry that you missed it. Let's get on with the tips and tricks for maths though, because they'll be more useful. In this video, we're focusing on this particular trick or this particular tip, and that is that you need to, in these multi-step questions, which are definitely going to be some of the trickier ones in your paper that you're going to do, you need to be able to think backwards before you work forwards. So what do I mean by that? I mean you need to see where you're trying to get to, work out the steps that you're going to need to go through in order to get there before you actually start working through them. So I'll explain what I mean in terms of this question. This question says find the area of the triangle below. Now it actually looks like a pretty straightforward question because you think, oh, area, no problems. I'm going to use the formula, area equals half AB sine C. And you think, I need two sides and one angle. Well, that looks good, two sides and one angle. But before you get too carried away, you need to think about where this angle needs to be in this formula. It needs to be between the two sides. So I need an A and a B and a C between those two sides. Now I definitely don't have that in this situation. I've got this and this, but I need this side here. So that's the side I need. So in terms of my steps so far, I know that my final step is going to be working out the area. I know that's my final one, and I'm going to use half AB sine C. I haven't got any other options, so I'm going to have to use that. But before I can do that, I know that I've got a step before this. And the step before this is that I need to work out theta, because I need theta in order to substitute it into this equation. So, how am I going to work out theta? Well, that's not necessarily immediately obvious either. I've got these two angles here and I've got these two sides here. I don't know this angle, so I can't just do a nice little calculation here using the angles of the triangle. So I think, oh, can I do anything with these sides? Well, I've got two sides and two angles. So hopefully when you think two sides and two angles, hopefully at this point your brain thinks, oh, sine rule. That'll be good. Use the sine rule. And because I'm trying to work out an angle, I'm going to use it in the form with the angle on top. Oh, you can't actually see that, can you? There you go. So that's the form that I'm going to use. So let's just double check. Have I got my pairs? Well, this is a nice pair, so I've certainly got one pair of an angle and a side. Now remember, it's tricky to just work out these random sides, so I think, oh, okay, I've always got to look at the side and find the angle opposite to that. So here's this side and here's the angle opposite to that. Unfortunately, that's not the angle that I'm after. But again, if I can see a few steps ahead, then I can see that if I work out this angle, and I can work out that angle, let's just call that angle, we'll give it another Greek letter, let's call it alpha. If I work out what alpha is, I'm going to work out alpha using the sine rule, because I know that that works beautifully here, so I'm going to use the sine rule. If I work out what alpha is, then I'm going to be able to work out what theta is, because this and this and this have to add up to 180. So if I know that this is 30, for example, and these two add to 160, this is going to have to be 20, the difference. So work out theta. How am I going to do that? I'm going to use that the angles in a triangle add to 180. That's how I'm going to work this out. So you can see here what I've done. I've said this is where I need to get to, but in order to get there, I need to jump through these kind of couple of hoops to get there. So I'm thinking backwards. Now I'm going to work forwards. So let's have a go at it. Work out what this angle alpha is. Well, I'm going to substitute in what I know. I'm trying to find that angle alpha, so I'm trying to find sine of alpha. I know that alpha pairs with 15, and I'm using this other pair, sine of 130, and I know that my side is 21. I might just do it up here a little bit so there's a bit more space. So I've got sine of alpha over 15 equals sine of 130 over 21. So remember, I bring this up and multiply, so I get sine of alpha equals 15 times sine 30 over 21. Whack it into my calculator. the, what am I doing? 15 times sine of 30 equals, and I'm dividing by 21, 0.357 is what I get for sine of alpha. And so then alpha is going to be, remember I've got to do the inverse sine. So to get rid of that sine, I've got to do the inverse sine. So I do, where is it on this calculator? Second function, inverse sine, and I'm after my answer. So it gives me that that angle there must be 20.92 degrees. So I've worked this out. I know that this is 20.92 now. So if I know that that's 20.92 and I know that that's 130, then I can work out what this must be. How am I going to do that? Well, I'll add these two together, 130 plus 20.92. So what is that? Let me add on 130. So I know that those two together add up to 150.92 degrees. So theta here must be 180, take away that, 150.92. So again, I'm going to do 180, I'm going to take away my answer that I just got. Gives me 29 degrees or 29.08 degrees. So I've worked out theta, that's good. Now I can finally get to the step that I wanted to do in the first place, which is to whack it into this equation. My A and B, it doesn't matter, remember, they're either side of my, my angle. So I'm going to just say A is 21, B is 15, and I'm multiplying by sine, sorry it's a little bit cramped here, sine of the angle I just worked out that theta was 29.08 degrees. So sine of 29.08. So again, whack it into my calculator, sine of that angle, and I'm multiplying by 21, 15 and a half. Gives me 76.54 meters squared as my area. I'll just do that final calculation again. You'll probably type in a half, but times 21 times 15 times sine of 29.08, 76.554 or 55. It looks like there's a bit of a rounding error, so that's okay there. Okay, so that's one example. You can see clearly how there's these multiple steps that you have to be able to work out. Here's another one. This one says find the length of AB and AD. So I'm asked to find this length, and I'm also asked to find this length. So let's just do one at a time. So I look at this and I can see that here's a triangle. That's that first triangle, A, B and O. And I know that this is 25, I know that this is 71. I'm trying to find this. Now if I'm trying to find this is a three sides guy and it's a non-right angle triangle, I'm going to need an angle. And I have to have the angle opposite what I'm trying to find. So in order to use the rule that I'm going to use here, which is going to be the three sides and an angle, that's going to be the cosine rule, I need to first of all work out what is that angle that I'm going to call theta. So again, this one doesn't have as many steps, but you can see that there's still multiple steps that you have to work your way through. So let's work out what theta is. Well, let's go back to our diagram. I know that B is on a bearing of 45 degrees. That means that from north, if I turned 45 degrees, I'd be facing B. So that's 45. It tells me that A is 320. So that means that I've turned all the way around 320 degrees. So that's all 320, which means this last bit must be 360 minus 320, because that'd get me the full circle. So this must be 40. So these two together are going to give me 85 degrees. So once I've got that, and I know that this is 85, I can use my cosine. So I've worked that out, I can use my cosine rule. I'm not going to do it here because I know we're sort of getting a little bit long in this video, but I'd be using this rule to work that out, where I'd substitute everything in. I'd let my A and B be B's, it doesn't matter which way, minus 2 times 25 times 71 times cos of, the angle I just worked out was 85. Whack it into my calculator, of course. This gives me c squared, so make sure you do the square root. That'll give me AB. AD is going to be similar, it's just a slightly different calculation to work out the angle. So same, I've got two sides, here's my triangle. I've got two sides, 25, 22. I'm trying to find that, but I need this angle, the one opposite. How do I work it out in this case? Well, I know that this point D is on a bearing of 240, so all the way around to there's 240, all the way around to there's 320. So the difference here, how much have I turned through here, is going to be the difference between these two. So that angle there is going to be 320 minus 240, because that's the extra bit I had to turn to get to 320, okay? So 320 minus 240, I think that gives me 80. My brain's getting tired. Again, once I've worked out that that angle's 80, I can use my formula again. A squared plus B squared minus 2AB cos C. Whack it in, doesn't matter which is A and B, call it A and B. 25 squared plus 22 squared minus 2 times 25 times 22 times, I'm getting a little bit out of space here, cos of, I just worked it out, was 80. Whack it into your calculator to get C squared. Don't forget to square root to get your C. So in these questions, and particularly obviously in this one, you can see that there's a number of steps that we have to jump through in order to get to the end point. Now they are going to be tricky for you, I know, but if you're trying to access a band 5 or 6 and even a band 4, you're certainly going to need to be able to do this level. This one, obviously, that's a little bit, but certainly harder, so it's more like a band 5 or 6. But this one here is, you know, certainly more like a band 3 or 4. So make sure you practice that process of thinking backwards so that you can work forwards. Good luck.